Picture our solar system. Imagine the vastness of space, the endless void dotted with stars, and at the center of our little corner, the sun. It's like a beautiful, peaceful dance, right? Each planet moves in a precise, predictable path, creating a harmonious rhythm that has been ongoing for billions of years. Planets swirling around the sun, all neat and tidy in their orbits. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, each with its own unique characteristics and distances from the sun. Earth, our home, is just the right distance from the sun, not too hot, not too cold. This perfect positioning allows life to flourish, providing the right conditions for water to exist in liquid form. Astronomers have been fascinated by this cosmic dance for ages. From ancient stargazers to modern scientists, the movements of the planets have been a source of wonder and study. It's like a perfect example of how physics works in the universe. The gravitational forces, the inertia, the delicate balance that keeps everything in motion. But there's a twist. Hidden in this cosmic ballet is a place of total chaos, the asteroid belt. Unlike the orderly orbits of the planets, the asteroid belt is a region of space where countless rocky bodies move in unpredictable ways. It's like a messy room between Mars and Jupiter, full of rocky stuff left over from when the solar system was formed. These remnants are the building blocks that never coalesced into a planet. It's a wild dance out there, not at all peaceful and quiet like the rest of the solar system. The asteroids collide, break apart, and sometimes even get flung out of the belt entirely, adding an element of unpredictability to our otherwise orderly solar system. This asteroid belt is huge. Stretching out over hundreds of millions of kilometers, it forms a vast ring of rocky debris that orbits the sun. It's like a cosmic junkyard, filled with remnants from the early days of our solar system. Imagine a place where countless rocks, some as small as pebbles, and others as large as mountains, drift endlessly in space. It's like a giant parking lot between Mars and Jupiter. But instead of cars, it's filled with asteroids, each one following its own unique path around the sun. This region is a dynamic and ever-changing landscape, where collisions and close encounters are a common occurrence. The gravitational pull of Mars and Jupiter plays a crucial role in shaping the orbits of these asteroids, creating a delicate balance that has persisted for billions of years. On one side you have Mars, the red planet, looking all rusty and old. Mars, with its iron-rich surface, gives off a reddish hue that has fascinated astronomers for centuries. Its landscape is dotted with ancient volcanoes, vast canyons, and dry riverbeds, hinting at a time when water once flowed across its surface. Mars is a planet of mystery and intrigue, a place that has captured the imagination of scientists and dreamers alike. On the other side is Jupiter, this massive gas giant, so big its gravity bosses around everything in the asteroid belt. Jupiter is a behemoth, with a mass more than 300 times that of Earth. Its swirling clouds and colorful bands are a testament to the turbulent atmosphere that lies beneath. The Great Red Spot, a gigantic storm larger than Earth, has been raging for centuries, a symbol of Jupiter's immense power and influence. This area between the two planets is packed with stuff. The asteroid belt is a crowded place, with millions of objects jostling for space. These asteroids come in all shapes and sizes, from tiny fragments to massive boulders. Some are made of rock, while others are composed of metal or a mixture of both. The diversity of these objects is a reflection of the complex processes that have shaped our solar system over billions of years. Millions and millions of objects, each zipping around the sun in its own way. Each asteroid follows a unique orbit, influenced by the gravitational forces of the sun and the planets. Some orbits are nearly circular, while others are highly elliptical, taking the asteroids on long journeys through the solar system. The constant motion of these objects creates a dynamic and ever-changing environment, where new collisions and interactions are always possible. Most of these are asteroids, like leftover rocks from when the solar system was a baby. These ancient relics are the building blocks of the planets, remnants from the time when our solar system was still forming. Studying these asteroids can provide valuable insights into the conditions and processes that shaped our cosmic neighborhood. They are like time capsules, preserving the history of our solar system in their rocky surfaces. They come in all sizes, from tiny pebbles to huge rocks like Ceres, which is so big it's almost like a mini-planet. the biggest thing in the asteroid belt. Ceres is a fascinating object, with a diameter of about 940 kilometers. It is so large that it has been classified as a dwarf planet, a testament to its unique status in the asteroid belt. Ceres has a complex surface, with craters, mountains, and even signs of water ice, making it a key target for scientific exploration. The asteroid belt isn't just a boring pile of rocks. It's actually super interesting, with all sorts of different stuff. Some asteroids, like Ceres, might have loads of ice hidden inside. Others are made of metal like iron and nickel. These different ingredients tell us a story about how our solar system was made. By studying these asteroids, scientists are like detectives, figuring out the history of our little corner of the universe. Each asteroid, every rock and ice chunk, is a clue to this giant cosmic puzzle. Section 4. Cosmic billiards. Planets move in nice, predictable circles. But the asteroids, they're all over the place. Jupiter's gravity, the Sun's gravity, even the gravity of other asteroids pulls them this way and that. It's like a giant game of billiards in space, with asteroids bumping into each other, breaking apart, and changing direction all the time. Imagine a dance floor with millions of people, all moving randomly, bumping into each other. That's the asteroid belt, a place where anything can happen. Section 5. Asteroid crash. Crashes happen all the time in the asteroid belt. When asteroids smash into each other, things get exciting. Small asteroids can break into tiny pieces, creating families of asteroids that follow similar paths. Big crashes can make craters, show what's hidden under the surface, and even change how an asteroid spins. These crashes might seem destructive, but they're also important. They make the asteroid belt more diverse and give scientists clues about what these space rocks are made of. Section 6. Gravity, the boss of space. Gravity is like the invisible boss of the universe. It's a force that we can't see, but its effects are everywhere. From the smallest particles to the largest galaxies, gravity is the glue that holds everything together. It controls everything, including the asteroid belt. The asteroid belt is a region of space filled with rocky debris and minor planets, located between the orbits of Mars and Jupiter. These asteroids are remnants from the early solar system, never forming into a planet due to the gravitational influence of Jupiter. Jupiter's gravity is so strong, it stops the asteroids from joining together to form a planet. Instead, it keeps them in a delicate balance, preventing collisions that could lead to the formation of a larger body. This gravitational tug-of-war has been going on for billions of years. Instead, they're stuck in this crazy, chaotic dance. The asteroids move in irregular orbits, constantly influenced by Jupiter's massive gravitational pull. This chaotic movement creates a dynamic and ever-changing environment within the belt. Over millions of years, Jupiter's gravity has shaped the asteroid belt, creating gaps and special zones where some orbits are allowed and others aren't. These gaps, known as Kirkwood gaps, are areas where the gravitational influence of Jupiter has cleared out the asteroids, creating distinct regions within the belt. Understanding gravity helps us guess what the asteroid belt will do in the future and how it might affect the planets closer to the Sun. By studying the gravitational interactions within the asteroid belt, scientists can predict potential changes in the orbits of asteroids and how these changes might impact the inner planets, including Earth.